Next speaker is also online, is remote speaker, my friend Jakob. And Jakob is presenting the latest state of development on OpenWebRX. OpenWebRX has a long tradition here at the SDRA because Andras Schretzler, the original author, presented it to a wider public here in Friedrichshafen on this stage at the very beginning 9 years ago. And as we said, a big part of open source is about handing over something, handing over a topic between generations and finding people who take care of something at later phases. So Jakob has taken over this project and takes care of it now and has been contributing to the project for quite a lot of time. And since OpenWebRX is an important piece of software in the SDR and the web SDR field, I asked him to give us an overview about the latest state of development. So as previously, we also pre-recorded Jakob's talk, and Jakob is here with us on the screen.
Hello.
He's going to answer your questions. Hi Jakob, hello. So I would like to ask the video team to play the pre-recorded talk, and then please think about your questions, and afterwards you can raise your questions to Jakob directly.
All right. Hello, everybody. I hope you're doing fine and you're having a good day here at the SDRA. My name is Jakob, and I'm here to tell you a little bit about OpenWebRX. Now, as I said, Jakob, my call sign, Delta Delta 5, Juliet Foxtrot Kilo. And for those of you who are wondering, yes, those are my actual initials. I'm a software developer, and I'm also a licensed ham since 2016. And back in the days when I was preparing for my ham license in 2016, I came across an interesting piece of activity called software-defined radio. And you'll have to thank Marcus for that, because he was the one who introduced me to it. And I also came across the concept of a web-based software-defined radio receiver. And OpenWebRX is one of those receivers. This is how the OpenWebRX interface looks like today. This is one of our receivers up on the Herzogstand, and it shows a very busy 70 centimeter band. And for those of you who have seen software-defined radio applications before, you'll probably be able to tell how this application works very quickly, and you'd probably get into it very easily. The software OpenWebRX is... No, what I'm going to be talking about today a little bit is I'm going to tell you a little bit about what OpenWebRX is, what it aims to be, what its mission statement is, or what the project goals are, and then we're going to do a bit of a deep dive into the architecture, and I'm going to take a quick look at some of the most recent changes in the software digital sound or digital signal processing chain and changes we've done there. Now, OpenWebRX itself, as I said, it's an open source, web-based, software-defined radio receiver. Now, I put up this little image here that I designed. Basically, what the concept of a web-based SDR receiver is: you have your antenna, ideally. You have a software-defined radio device. I'm not going to specify it any closer. You can use an RTL SDR, you can use other brands. OpenWebRX supports a variety of hardware. You have a Linux server, and the cloud in the middle is basically signifying any kind of network environment. And yes, that can be the internet. And on the right-hand side, you have the clients. I've drawn Chrome and Firefox as an example, but just to give you the idea that a browser is enough to use the software itself. There is no software you need to install on your PC. It all happens in the browser. Now, if you want to try out OpenWebRX, you don't have to do anything other than go on the web, find one of these receivers with your computer, browse there, and I've put this map here just to show that there is receivers in many parts of the world. This is a snapshot from today. It changes. There is new receivers added almost daily. This is just to show you that there is a lot of options available already. And as I said, you don't need to have to install any software. All you need is your browser, which I'd consider it to be a given these days. And you can go off. This map, by the way, you can find that on Receiverbook. I'll have the links up at the end of the presentation for you. What is OpenWebRX? As I said, I came across OpenWebRX in 2016, and also I believe this is not the first time that OpenWebRX has been a topic at the SDRA. I was in a presentation myself in 2017, back when the original author, Andras, was giving a talk about OpenWebRX in Friedrichshafen. And I have picked up the project back in 2019, I believe, and have continued to develop it ever since. Now, where do I think the project should go? Where do I put the focus in the development work on OpenWebRX? The main focus is it's supposed to be a software that you can install at an interesting receiver site where you have interesting antennas, interesting locations, or are able to receive signals that are interesting. That usually is when you're having a good and silent position for shortwave, or when you're having a very exposed high application for VHF and UHF, stuff like that. The second point is the focus is on multi-user support. Now, just as an example, this is mostly for decision making. So whenever a feature request comes up, I'll have to look at things like this and have to decide whether or not to include it. And one of those that I've had to turn down is whenever somebody says, and whenever somebody comes up and says, hey, it's nice that this is a receiver, but can we also transmit with it? And I'm like, yeah, but the moment one of those users transmit, the others can't listen anymore. And that is why focus is on multi-user support, and that is why probably, unless somebody can solve that eternal problem, it's always going to stay a receiver-only software, just as an example. Now, ease of use over sophistication. The OpenWebRX project mainly focuses on being a simple-to-use interface. And that comes basically with the whole, it's web-based package, mostly because it aims to be an entry-level piece of software. So users who just want to try it out, they don't want to install anything. You have your browser, you can go to a site and you can click it and experience like what software-defined radio is, how it works, and so very entry-level kind of software. That's why it should be easy to use. Now, I don't object to advanced features, but it has to be integrated in a way that it doesn't interfere, it doesn't distract users, or it needs to have a good ease of use user experience. Integrating decoders over client-side decoding support. I know many of you are used to simply running a piece of software and on your computer and then using virtual audio cables and feeding audio into this. And if it works for you, that's fine. It's just that I've had requests for it increased bandwidth or sharing raw IQ data, and I'm like, that's all fine and dandy, but I'd like to integrate the actual receiver. The idea here is that, once again, you don't need to install software. So additional decoders should be integrated into OpenWebRX itself so that everybody can use them directly from their browser. Code quality and longevity over a multitude of features. I would like the project to be maintainable. I guess as a developer, I don't have to put any more emphasis on that. Focus on availability and accessibility. The software should be stable. It should be accessible. It should be easy to use, as stated before. And the last point, make use of idle resources without interfering with receiver clients. That is basically what many of you already know as background decoding. So OpenWebRX can make use of devices that are not currently in use by users and do spotting and reporting on these devices. This, however, is low priority, and whenever a user comes in and wants to use our device, that activity will be terminated. Now, let's have a bit of a look at what OpenWebRX is. I've taken this slide again, just to give you an idea. Now we're looking at what is happening inside that Linux machine, the red square there. What is happening? What does the software do in order to present you with what you're seeing? This is not as interesting if you just want to use the website. This is more of an interest if you actually want to set up one of these receivers yourself. This is the basic data processing pipeline in OpenWebRX. As you can see on the left, I have put down a number of software-defined radio devices. You can use as many as you want and as many as your hardware supports. The one thing most people will run into is usually the USB bandwidth. That is typically the limit of how many SDR devices you can run. But you can have as many as you want as far as the software itself goes. The data then passes through either a connector or a classical IQ source that is hardware dependent, and then the NMUX TCP distribution. Doesn't matter. Both of these are pretty much equivalent as far as function goes. Then we're splitting up the path. We have a waterfall DSP that does the FFT transformation, averaging, and basically it transforms the IQ data into waterfall data. That waterfall DSP runs only once per device and is then distributed across all users. And then we have the demodulation DSP, as I've called it. That is actually where the audio and potentially any additional metadata that you're going to see on your screen is produced. That part is, if you set AM as your receiver mode, that part is where AM will be switched. Now, the data of both of these things together is combined and sent over a WebSocket to your client, PC, laptop, whatever you're using. And there it is rendered inside the web interface. Now, I've also shown a little bit at the bottom there in blue that there is also a bit of background activity. There is a scheduler and there's background decoding. As I said, these things can be enabled. They're optional. You can use those to decode pretty much any of the WSJTX modes, like FT8, FT4, Whisper. Pretty sure I'm forgetting some, but whatever. You can also do JT8, JS8, I'm sorry. And you can decode all these modes, not only in the browser, but also in the background, and then process that data and send it on to PSK reporter, WhisperNet. We also have APRS decoding. So if you're having a VHF receiver, you can set it up to decode APRS and send the decoded data to APRS.fi. And also that little dotted arrow that comes down from the demodulation DSP, that signifies that if a user decodes any of these modes, the data is also made available to the reporting interface. So if a user decodes FT8 and your reporting is enabled, that data will also be sent to PSK reporter, for example. Now, we're going to dive even deeper. Now we're going into the little block called demodulation DSP here, where we're going to look at what the recent changes is in the DSP processing, how the DSP processing is done. Now this is old stuff. This is how the demodulation pipeline looked like before OpenWebRX 1.2. Some of you may have seen this because it's actually logged in older versions, and it's a lot of text. But if you look closer, some of these terms may look familiar, and people who have worked with GNU Radio, for example, they may recognize part of this, and it is technically not very different from a GNU Radio pipeline, because all that happens here is the data is passed from the first step to the second, to the third, and so on. The data is just passed through all of these commands, and in the end, you get basically an audio data stream. I have broken this down a little bit. The green box at the top, the NC command, that is basically just the source that provides us with the IQ data. It reads the data from the connector. And I've also included the class names of what it is now. So now, instead of NC, we're using a PyCSDR TCP source. The blue box is basically nothing more than the selection and bandpass to filter out, like if you have your if you have an SDR device, your SDR device is providing you with a full spectrum bandwidth of 2 megahertz, 10 megahertz, depends on the device. And what the blue box basically does is it centers that around your desired signal. It shifts that to the middle. It makes it does a decimation so that it's only the selected signal. It makes a band pass, so you have a very narrow signal. It's basically all just crunching down the numbers, so you have that one signal still as an IQ signal. The red box, I've picked this example to be an AM demod, which is an AM signal simply because it's one of the simpler ones. That does the AM demodulation. It does a DC blocker and an AGC. That's basically the actual demodulation of that signal. And the red block could actually be something else, depending on what modulation you're selecting. And the purple box at the bottom, that is actually just audio processing. It's encoded into an ADPCM codec for transport to the client in order to save some bandwidth. And as you can see on the right, the blue box is now a selector chain, CSDR chain selector. The red box is replaced by a few. I'll have an example on the next slide. And the purple box is now a CSDR chain client audio. All that is basically from the left to the right what we have changed. Now, here I've picked up, like, once again, that is the red box from before. And you can see that what used to be 3 separate commands is now in the code basically one class that has 1, 2, 3 workers that basically correlate to what they were before. It's one of the easier examples. That's why I picked this one out. Others are not as easy to see or spot, but I think you can see here that you have first you have the initialization of the AGC. The AGC needs a few parameters, and then you have the 3 workers, and that is the initialization of the chain. So basically, it's not that different. It's just a different way of writing the pipeline, so to speak. And the components are now basically reusable. The pipeline is not just one big command. You have separate pieces, and the selector is reusable and stuff like that. So that's basically the major change here. The DSP chain itself, now what has happened in the background? Like, that's just what you see when you look in OpenWebRX code, but the whole DSP pipeline has also been restructured. The implementation of all these different modules that you've seen in the list before, they have been rewritten with a common module API. I'll get to that in a second. The modules are now exposed in the form of a Python API. What you've seen before, that was Python code. So you can now instantiate the modules directly from Python instead of having to call a shell command. The module API is also exported for reusability. The library is called libcsdr++ because it's written in C++. And it's also used, or it is written in a way that should make it easy to use in third-party modules. And I've also included an example. DigiHam, for example, has been restructured as well to use that module structure. So you can now use DigiHam modules directly in OpenWebRX code, which makes it very easy to integrate. Now, the DSP itself is still in C code. The DSP, even though it has Python bindings, when you call the DSP, the actual implementation in the background is still C++ code. So it runs still as efficient as before. And it still also runs, like every one of those modules you've seen runs as its own threads, which is important these days because that is the way you make use of multi CPU systems. So basically, what that says is nothing else than it can use a modern day CPU to 100%. And the whole process, all of that work, reduced the CPU usage in typical scenarios, the CPU usage of OpenWebRX as a whole, to about 70% of what it was before. It's a bit hardware dependent. Not every measurement is the same. That's why I'm saying about 70%. Your mileage may vary. It's not that much, but for a Raspberry Pi, for example, that used to be able to handle 5 clients before, that means you're now up to 7, maybe 8 clients. It's not too bad. I'd say that's what's worth it. This is what I said before. This is the module API. So when you want to implement a module that can run in that new DSP pipeline, that's basically what you implement. There, I've put a red box around the 2 methods that are important. The others, they have default implementation somewhere down the line. All you have to do is you have to implement a method that can tell the runner whether or not the data that is available right now is sufficient for the module to process something. And then when the runner decides it's time to do so, the runner will call process, and then the module is going to do whatever it has to do with that data. That's all there is. All that is to it. that is the very basic API of a module. It's still pretty simple if you want to implement your own. And there is a few other subclasses of that module available that I'm not going to go into, but if you want to have a more simplified API, there is a few other tastes of that module implementation available. All right. I think that's already about it. I promised some links. So if you want to have more details about OpenWebRX, if you want to set up your own receiver, if you want to experiment a little, come to the OpenWebRX webpage. You'll find more information there. We have a wiki with information. We have a mailing list for support. We have a Discord server if you want to chat with somebody. All of that you'll find through the first link. And the second link, Receiver Book, that is the new receiver indexing dictionary where you can find a listing of receivers. It's not limited to OpenWebRX. The Receiver Book basically lists various types of web-based receivers. It includes Kiwi SDR, it includes the WebSDR, all of that, because as far as I'm concerned, it doesn't matter what type of software you're using. If you're exposing it on the web as a service, that is a web-based receiver, so it's listed in Receiver Book. And yeah, have some fun. I'd like to thank you all very much for your attention. I'm not going to ask for questions right now because we're going to have a Q&A in the live channel once this recorded presentation is over. So thank you very much. Enjoy your stay at the M Radio Friedrichshafen, and bye-bye.
Okay, so interesting talk. I know OpenWebRX anyway. We've been talking about many things, Jakob, and supporting the USRP and whatever, what I have in my place. So, yeah. Pretty cool piece of code. Now, your questions.
Yeah, how many channels did you say you handle simultaneously, and what system is that running on?
It's completely depending on what type of hardware you're using. That was just a few numbers for an example of a Raspberry Pi that can handle up to 5 users. But as you can imagine, a Raspberry Pi is...
Come talk to me.
Oh, you can't hear me?
I'm Phil, KA9Q. If you want to handle several hundred simultaneous channels on a Raspberry Pi, come talk to me. I have a project called KA9Q Radio you might want to play with.
Oh, I'm aware of that one. I've seen that. Thank you.
Who's been using OpenWebRX? Oh, quite a number of people. Very good. So this has become quite a good and lively community, and I think OpenWebRX is one of the most influential pieces of software around.
Maybe just a question regarding how does OpenWebRX relate to Kiwi SDR project, because I understood that it was the same project basically, but is it developed in parallel now? How does it work?
That is part of OpenWebRX history. Basically, that all happened before I started development on the project. Back in 2000, I think that was also in 2016, the Kiwi SDR project was basically forked from OpenWebRX, and it implemented a new backend, and it only supports the Kiwi SDR hardware. It's hardware specific, and it does, so basically it still implements the classical, well, it has diverged since then, let's put it like that, It had the OpenWebRX user interface of that time to start with, but Kiwi SDR developers have also added a lot of new features to their software. But since the backend has been switched out and a lot of the Kiwi SDR implementation runs, I believe, I'm not exactly sure about the technical details of the Kiwi SDR project, but as far as I'm aware, the Kiwi SDR actually offloads a lot of processing on the FPGA that sits on the Kiwi SDR hardware. It is quite different, and you can't easily switch or port code between the two projects today, unfortunately. And since that fork happened years ago, the projects have diverged. You can still see it. I think Kiwi SDR interface still says OpenWebRX in the corner or something like that. But they still have their historical similarities, but it's not the same software anymore, I'd say.
Okay. So we've been running out of time. 3:15 now. Jakob, thank you very much for your contribution. Thanks for your work.